Okay, this is lab 6, activity 2, and in this activity, I will create this folded sheet metal, not by extracting the surfaces of a block as I did in activity 1, but what I will do is I will draw an L-shaped, an L, basically an L as a sketch, and then extrude that to create a surface. Okay. The rest of the problem is the same. The bottom is clamped and the top is subjected to pressure. The bottom edges are clamped. The other thing is that you're supposed to use as many planes of symmetry, and this is why modeling 1/4 of that is the way to go. And you need to use shell elements for this particular problem. Okay, so let's go ahead here and start with the part file. But because I'm dealing with surfaces without the actually making a three-dimensional part, uh, so I can do that wireframe or surface design or generative shape design, which are already on here. Wireframe and surface design, which is a workbench in mechanical design, is a stripped down version of basically this generative shape design. So on this plane, I will sketch basically my L. It looks like that. And I'm going to put some dimensions here. So this is based on my drawing, uh, half an inch. Let me see for a second. I'm drawing this, uh, sorry, 1 inch, because this whole thing is 2 inches. Okay, so this is 2 inches. This is 1 inch. This is 1 inch, and this height is half an inch. 0.5. Say okay, exit. And we're going to create a surface directly by extruding that. So if you look at the way you make surfaces, this one is the first one says extrude, and the direction of it doesn't matter. So I'm going to make this thing, this was 2 inches long. So that's 2 inches long. Let's make sure. Yeah, the whole thing is 4, half of that is 2 inches. So what you see here is basically the surface. Now, because of what I did, namely drawing a sketch and then extruding it, there won't be a seam, uh, when you measure uh, this thing, first of all, does not have to be joined, because you will see that even without joining, you'll have identical nodes on both sides of this. Okay. All right, so let's apply material to this thing. Material, I think I used yellow brass on this. I don't need to join this thing. If you want, go ahead and do it, but it's not, basically doesn't do anything. Now, uh, okay, so we're done here. We're going to go to analysis and simulation, generative structure analysis. Now, notice that when I did this thing earlier, activity one, I extracted these surfaces, and of course I extract from a block that was created. And as soon as I went to the generative structure analysis, Catia saw that block and meshed it. So I had to go and delete the three-dimensional mesh, the octahedral tetrahedral element mesh, and the 3D property. Now, there is no three-dimensional object here, therefore nothing got meshed. So I have to do that myself. So here is the octahedral triangle mesher. You select this thing. I didn't have to join it because the way this was created, the entire thing is meshed at once. Uh, I'll use the same. I, I don't remember what this mesh size was there, but I'll keep it like this. I'm pretty sure it was smaller than this, but that's okay. But the type is parabolic. Okay. You want to see the mesh, right click, mesh visualization. The mesh is there. Change the rendering here so that you can see the edges right there. I'm sure the activity one I use the finer mesh, but that's okay. That's really not the point here. Now, deactivate this. Now the uh, define the thickness of this, and that is 2D property right there. See, this is 3D property, 2D property, 1D property for beams. You click on that, you select this, and because these were already this is already one surface. When I put a uh, thickness on it, first of all, it took the one from activity 1.1. If you want to change it, go ahead, do that, but we don't, and pick the right material, so that's good. All right. The bottom of this thing is clamp right there. And let's see now. For example, we can say this edge and that edge lies in the plane of symmetry of XZ. So let's do that. Let's uncheck all of these first. Make sure we start from scratch. So this edge and that edge, or the other side, it doesn't matter, either one. Oops. These two edges lie in the XZ plane, and therefore they don't move in the direction Y, and rotations are exactly the opposite. There we are. And this edge, on the other hand, this edge lies in the YZ plane. So let's do that. I wish there was a clear all button here, but no such thing. So this edge lies in the YZ plane. It does not move in the direction X, and rotations are exactly the opposite. Same thing that we used in beams. That's pretty much it. And the pressure on top of this is 100 psi. Now notice that I don't have a control. I mean, obviously, this is not how I want it loaded. First of all, this is not the proper direction. So let me change this into minus. Oop, go back here. Where is my load? There is a load. Double click, put a minus so that it goes in the other direction. Now this is the way I want the surface to be loaded, pushed down basically. Now, if you say that, well, is there a way that I can put these arrows on top of that? The answer is yes, but that's not important right now. It's not important, okay? But for visual purposes, it is possible to do something in the generative shape design so that these arrows are showing on top. But I'm not going to do that here. That's really not the focus. And that's pretty much it. So let's go ahead and run it. We did in activity one the same problem, except that created the mesh a different way. You can look at the deformation, and let me see for a second. If you see, well, why does it look like it deflects a lot more than what I already saw? That's because of the mesh. The mesh is terrible. uh, yeah. So anyway, deflections right there. The pattern looks pretty much the same. Change to the rendering to material, looks like that. And you can look at the von Mises stress, etc. Yeah. Now remember that without mesh convergence study, anything that you do in finite element, you might as well tear it up and throw it away. Okay. You really have to do a mesh convergence study to see how good your mesh is. Is it reliable or not? Without that, these are just numbers that you're generating, maybe totally useless as far as the real application is concerned. Okay. That takes care of the activity 2, where I created the surface based on plane extrusion. Activities 4 and activities 3 and 4 is going to be considered the case that the thickness of the top face is different from the thickness of the side face. So we're going to do that.